So this is the question of height and distance which I have put into my short study, and I'm going to explain this question in detail today, right? So what the question? Let me read it out. As per the question, from the top of a lighthouse, from the top of a lighthouse. So let's say there is a lighthouse. If this is the lighthouse, let's say, lighthouse is present in the middle of the sea just to give light to the ships. Okay, so let's say this is the lighthouse. This is the lighthouse, right? If this is the lighthouse, actually this is just like a high mast pole. Okay, from this lighthouse, the question is that from the top of a lighthouse, the angle of depression of two ships. So two ships are there. The angle of depression of two ships. Just consider these ships as a point only. Don't, because from the height it will look as a point only, right? So if A and B is the lighthouse and C is the ship, but it's given that ships, not ship. So two ships. So the angle of depression of two ships on the opposite sides of it. That means if this is the lighthouse, one ship is in this side and one ship is opposite to this ship. That means opposite side of this ship with respect to this lighthouse. Then another ship is here, right? Let's say this is at D. This is the position D, right? And from here, it's given that from the top of a lighthouse, the angle of depression of two ships on the opposite sides of it are observed to be alpha and beta. So from here, from here, if you are seeing these ships, if this is the ship, right, and this is another ship, right, then the angle of depression, if just consider this as a horizontal line, just parallel to the horizon, if this is the horizontal line of ground, right, then the angle of depression from the top of the lighthouse for the two ships are alpha and beta respectively. So, angle of depression will be formed when you are seeing something downward. So this is the angle of depression when you are seeing the ship C from the top of the lighthouse, and let's say this is alpha. Similarly, the angle of depression of this ship from the lighthouse is this one, beta, for the second ship. So there are two angle of depressions, one is alpha and one is beta. Alpha for this ship at C and beta for the ship at D, right? Now, if these two angles of depressions are alpha and beta for ship C and D, then in this question of height and distance, we need to prove that if the height of the lighthouse be h meter, if this lighthouse is h meter high, if this is h, right, then we need to find the distance between the two ships. This need to be calculated, right? This need to be calculated. Students, in this question, it's very clear that from the top of a lighthouse, the angle of depression of two ships on the opposite sides of it are observed to be alpha and beta, right? And if the height of the lighthouse be H, here I have mentioned it, right? If the height of the lighthouse be H and the line joining the ships passes through the foot of the lighthouse. So these are the ships. If these are the two ships, though it looks like a boat over here, but don't worry, it is a ship as per the question. Yes. So the line, it just when you joining the line of these two ships, it passes through the foot of this lighthouse, right? Now we need to show that the distance between the two ships is h times tan alpha plus tan beta divided by tan alpha tan beta. Students, this is very good question, and for CD we need to prove it, right? So in this question what we do, how to prove this, let us see. Students, here you can see if this AB is the lighthouse whose length is equal to h, you can see AB is the lighthouse whose length or height is equal to h, right? Now we need to prove and C D are two positions of ship ships in fact because there are two ships, one is at C, this one, and one is at D, this one, right? So in this we need to prove the distance between C and D, that is the distance between the two ships, as h tan alpha plus tan beta by tan alpha tan beta, right? Tan alpha into tan beta, this should be into the denominator. So what we will do, we just consider this triangle first, triangle ABC. Triangle ABC, if this is the angle of depression alpha and these are two parallel lines, consider like this, right? This line crossing through the foot of the lighthouse, then this angle is alpha, then definitely this angle, let's say if PQ, if PAC is alpha, then ACB is also equal to alpha. I have put the sorts of this question yesterday and I am explaining it today, right? If this is alpha, then angle of depression is alpha, then this can be converted as angle of elevation from the boat, because the angle of depression was from the top of the lighthouse, and if this alpha is equal to this alpha, because angle PAC is equal to angle ACB, because these are alternate angles. So this angle of depression is converted into angle of elevation over here. Similarly, from the top of the lighthouse, this beta is the angle of depression for the second ship, and this beta can be converted over here as angle of elevation from the ship, right? So what was there from the top of the lighthouse, that angle of depression is converted to angle of elevation from the ship. Okay, from the top you are looking downward, and from the ship you are looking upward. So angle of elevation will be formed only when you are seeing something upward which is higher from you. Okay, and angle of depression is formed only when you are looking something which is less than the height of you. So from the height of the lighthouse, these ships are looking lower. That means you is downward. So that's why this angle of depression is formed. Now we need to prove that what is the angle between this angle between the distance between CD is this much, right? For this we consider this triangle first, triangle ABC. So I'm writing it over here. In triangle ABC, what's that? in triangle ABC, just take the tangent, because here you can see it's tan 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 tan, right? So just take only tan and let's see what happens. So for tan alpha, tan alpha is AB by BC, right? What's the height of AB? It's H, and BC, it can be written as, just bring tan alpha this side, BC can be written as H by tan alpha, right? So just keep it as it is. We have calculated the length of BC. So the length of BC is H by tan alpha. This is H by tan alpha. That means from B. So this is B point, the base of the tower. And from B to C, H by tan alpha, we have calculated it. So from here to here is calculated H by tan alpha, right? Now consider the another triangle. Which triangle? Another triangle. Which triangle? Triangle ABD. So in triangle ABD, let us see, students, what happens. In triangle ABD, this one, tangent of beta, tan beta is equal to height of the tower, that means AB. This is the perpendicular by the base, that is BD. So AB by BD, and when you just do cross multiplication, this BD will go into the LHS and tan beta will come into the denominator of RHS. So we can write BD as AB by tan beta. And what's the value of AB? AB is H. So it's H by tan beta. So this is the another relation which we have derived. Now this question is almost solved, students. This is H by tan beta, right? Now you know the length of BC now, you know the length of BD now. So can we write it that the distance between two ships is equal to what? It's equal to C to D. It's equal to C to D, right? Distance between CD is the distance between two ships. So that's equal to C to D, and CD, that is the distance between two ships, can be written as BC plus BD. CD can be written as BC plus BD. And what's the value of BC? We have calculated BC as H by tan alpha. Just put up the value over here. That's it. H by tan alpha, and in place of BD just put the value H by tan beta. This H by tan beta. Simple arithmetic calculation. Take the LCM. On taking LCM is tan alpha into tan beta, right? And here is tan alpha, so tan beta will come here. So H tan beta plus alpha, H tan alpha will be second term of the numerator. Here you can see we have almost proved that what was required. That means it can be written as taking h common, tan alpha plus tan beta into the numerator, tan alpha plus tan beta, because we are putting tan beta plus tan alpha can be written as tan alpha plus tan beta after taking h common, right? And into the denominator we have tan alpha into tan beta. So in this way we have proved the distance between two ships as h tan alpha plus tan beta by tan alpha minus tan alpha into tan beta, right? So students, you have seen how we solve this question of height and distance. I will say just like and subscribe to my channel and keep on learning. Happy learning. Bye bye.